Hello, everyone. Thanks for your time today. Today, the first day of the Open Nebula Conf, and let's go with the panel about confidential computing. I'm sure that you're enjoying all this conference and trying to see how the edge, is powering new opportunities. Perfect. For today, we have a specific panel to see the future or the present of confidential technologies. And let's start with this first introduction from Open Nebula. Here, Jordi Harro as a moderator for this panel. Okay, let's introduce the different participants of the panel. Mona from Intel, Jaroslav from SUSE, Francois for OVH, and myself. Okay, let's go. I'm sure that you could discover during these sessions that edge computing has a lot of opportunities around. We were discussing some years ago about centralizing through the hyperscalers all our infrastructure and services and workload. Now we are focusing on new trend where in the next years we will see this reduction where the edge will be more or less the key for everyone. And this opportunity, it's aligned with something that we call continuum. And through the continuum, we will be capable to provide low latency services from meters to kilometers and to be more near the user requirements. Okay, this I think it is clear. And about all these topics that we will discuss today and all these opportunities, we have a next generation services from the next years where people from or companies like Intel, SUSE, OVH, Open Nebula can have a specific role to do this. And what about confidential computing? In this case, another opportunities arise around all these technologies that we know that are very consolidated in the data center, but when we'll see during this panel is about some challenges in a distributed conditions, like this continuum, this edge cloud continuum will arise. Okay, after this introduction, let's see our presenters, our participants from this panel, and let's go with a first round of introductions. We can go, in order from initially from Intel, after SUSE, after OVH, and let's go. Thanks for being today with us, and let's go with this first introduction.
I'm a senior principal engineer at Intel Labs. I've been at Intel for almost 25 years. I am part of security and privacy research and have been part of the confidential computing team since the technology was incepted at Intel. Yeah, go on.
Hello, I'm Yaroslav Kornilov. I'm from SUSE. I'm a product manager and I'm working with virtualization technologies. And naturally, when SUSE joined the confidential computing, I was privileged to have a chance to work with that technology. Thank you for inviting me.
Hello, François Puig from OVH Cloud. I'm the pre-sales manager of OVH in France. At OVH, we have several offers, cloud offers, and on the bare metal servers, which is the basis for all our systems, we offer confidential computing based on Intel technology.
Okay, perfect. I saw that you are connected. At the end, confidential computing is something that now is a hot topic. And let's see if we can discover through this panel the present and the near future about all this technology and around all the challenges that the edge is providing to us. Okay, for the first, we have 3 blocks. The first block is basically to introduce the different details for each of the participants and the technology or the service that they are providing. Okay, the first one is Intel. Mona, congratulations with all that you are doing in the field. It's clear, and it's clear you are a pioneer, no, in developing hardware-based security solutions from Intel engineering position. And let's introduce confidential computing technology. Can you elaborate more or less how Intel, no, in this case for the hardware perspective, such as services like XGX and another, are enhancing data privacy and security in the cloud? And what about the future advances that can we expect from Intel in this domain?
Sure, sure. Yeah, I think just so we level set, right? Let's start with the definition for confidential computing. And as many of your audience may know, there is a confidential computing consortium, which is a Linux Foundation group, and they define confidential computing to be protection of data in use by performing computations in a hardware-based trusted execution environment, or a TEE. So today we know how to protect data when it's in transit. We can encrypt it. We can protect the data when it's on the unstored, but it completely comes in clear when it's being processed, and that's where confidential compute comes in play. So when I say a trusted execution environment, it is an area in the processor, memory, and CPU where anything that you're running inside, both code and data, is protected from rest of the environment. And there are certain properties we expect from all the TEEs. We offer Most TEEs will offer confidentiality via encryption and key control, and verification of code and data via a process called attestation. That is very powerful, because not only that you get confidentiality integrity guarantees, you can prove to a third party that you're indeed running in an enclave. So actually, as you mentioned, Intel pioneered this space and actually helped coin this term confidential computing with Intel SGX, which is application isolation. And but most recently, Intel also introduced a VM isolation technology called Intel TTX. And this is today on CPUs only, but Intel is also working on extending the trust boundaries from CPU to GPUs or other accelerators via technology called TDX Connect. And again, just to give an idea, TDX Connect is a standards based approach where you can extend the trust from a TD to a trustable device. And TDX Connect is built on top of several a suite of standard protocols. So there is TDISP, which basically helps you establish trust between a TE and an accelerator, IDE for link encryption, and then there is another protocol, SPTM, which is for device authentication and attestation. So today, actually, Intel does offer a software-based solution that works with NVIDIA GPUs. NVIDIA H100 offers a bounce buffers-based solution where you can encrypt anything that you've sent to the device, and then same thing, decrypt back. And that actually is available today, but in future with TDX Connect, it will be extended to large classes of devices. Uh, I would say that's where the roadmap is. And once, imagine if we have this heterogeneous environment running in multi clouds with different heterogeneous and disaggregated nodes, we should be able to deploy confidential computing across the board. Yes, I
Okay.
would stop there. Yes.
No. Perfect, Mona. Like the introduction was clever, and I'm sure that for the audience helped that what we are discussing, and happy to see and to listen that maybe coprocessors, smart NICs can go play,
Mhm.
some specific role in the edge. Perfect. As you can see, we are following most of the layers. We have the Intel, the hardware. Let's go, with in this case with SUSE and the products, that you are, developing. Here is my question, Jaroslav. From OVH, it's not that, uh, you know, how OVH is leveraging confidential computing to differentiate services for a competitive market. No, we have different uh, options. And what SUSE is integrating confidential computing into its cloud offerings, okay, in his products. And at the end, the last question is, what for you, what are the key challenges you have encountered, and who are you addressing them to ensure for your customers' safety?
Okay, thanks for asking. We SUSE is an operating system vendor. We do more than just operating system, but obviously that's our key competence and the key thing that we deliver to this confidential computing table is the operating system that is able to be as a guest and deliver all necessary confidential computing services that is required. And here we have we since last year we all operating systems that we deliver they are able to be a perfect guest in the confidential computing environment or to use the Intel TX features available and that actually covers the full range of operating system portfolio we have, starting from the flagship enterprise, starting from the edge friendly SUSE Micro that is the operating system for edge and all other cases like Edge. So we deliver operating system that is able to run on confidential computing. That's clear. But what else do you get as an end customer? So you get the operating system that is certified and has all the delivery supply chain certification, which is really important for everyone who is concerned about confidential computing to be sure that the operating system that you're running has no man in the middle implants inside. So you have these these confidence in our operating system. So that's the first layer, and the second layer it would be the attestation. Attestation is the proof that as an end user you ask the system to run the your application inside the confidential computing VM, but you also get a proofs from down from the silicon that is actually running at the moment in real time. And here we are more than just the operating system vendor, we are active contributor. We recently we add a project Coconut SVSM to the confidential computing consortium, and everyone who would like to get the attestation proof can rely on secure virtual TPM to get this information. So we are not only getting benefit from being part of the open source community, but we also contributing back into the community. So that's basically the what we can deliver to this discussion. And the challenge is the biggest challenge is probably in attestation. Attestation is not that simple as you might wish to have it. It's not really a binary yes no which an end user would expect, and we all as an industry should drive to. At the moment, the attestation as a process, as a result of attestation process, you get certain information that would require an interpretation from an end user. And to give the example what it might be, you as an end user you get the hash of the bias of your VM, and the bias was create is a binary delivered by the environment, the provider. Do you trust provider? Do you trust this binary? You see only hash, and you it's really something that you have to interpret, and you have to add some confidence in that. And we have to deal with that and improve that in the future. So that was my 4 or 5 minutes. Thank you.
Yes, perfect, perfect. You are respecting the time slot. This is for me. It's perfect. Thanks to see the operating system view and this strategy when you mentioned the different strategies to put all the VM inside the TEE or outside, or to go or deal with the different attestations, no, that at the end is you are playing in the game. Perfect. Let's see no the evolution of this. And now with Francois, it's your turn to receive another question that we will cover not from the hardware and operating system, some extra insights and information is how, in this case, OVH with all these, around and building, your robust cloud infrastructure, no? How OVH is leveraging confidential computing to differentiate its services in a competitive market, no, with another companies. If you can share any specific use case, no, where confidential computing has significantly improved security and performance for your customers that we know that are always, no, looking for extra security.
Yes. First, yes, I would like to say that we are totally involved in confidential computing since the first release of SGX and also TDX. So we have deployed these technologies on our bare metal servers. As I've said, these bare metal servers are the basis for all our technology. That means that later on we will find confidential computing on public cloud, VM instances, Kubernetes, etc. The use case we meet at the beginning, most of the customers interested in confidential computing were mainly financial institutions or healthcare organizations. For the financials, confidential computing was consequently used in particular in fraud detection because it allows to deeply analyze the data to detect fraud without giving access to the data itself. In the same way, healthcare organizations are using confidential computing in AI training. That allows to train the application on AI data without giving access to the data itself to the user. But in the recent days, nowadays, most of the customers coming to use confidential computing are mainly blockchain customers. In blockchain, the breaches exploited in the last years were linked to encryption key and when the key was transferred or used. So the idea to encrypt in memory the key allows to avoid such breaches. So that's our main use case of confidential computing at OVH.
Okay, perfect. Thanks for your answer. We discover how the blockchain, no, world is, invading the data centers.
Yeah.
And for these new features is clear. And I catch that is the typical financial and health, no, sector. They are more no, I have to explain that they are more cautelous, no, to use, no, in this case, cloud computing in general, and we are sure that it is changing for financial, for instance, and schemas like Dora, no, that now they have to follow, and I think that they have to follow in the next January 2025. Sure that this kind of technology has to have this extra solution to adopt, cloud and edge computing. Perfect. Was we cover, the three first, immersion, in the mouth of our experts, and let's go with the additional block. The next block is a question for all the participants. We are, in the same conditions, in the game, and let's go with this because at the end, no, confidential computing, we have a specific offer among, your products and services. This is clear, but we have some extra complexities, no, around, the strategies that for the workload selection and how you are, using this kind of technology. For your point of view, what are some of the common misconceptions about, in this case, confidential computing, and how can the industry better educate business and users about the benefits and the different implementation strategies? We can continue with the same order. Mona, Yaroslav, and Francois. Please, Mona, the floor is yours.
Sure, sure. Yeah, so I think while in my mind, while confidential computing is a foundational technology to help protect your data confidentiality and integrity, It's not a panacea. It's not a solution to solve all your problems. Yeah. So first of all, and also by the way, we talk about confidential computing mostly in the context of public cloud, right? The goal is to be able to sort of create this private cloud within the public cloud by using confidential computing, because you don't have to trust the host software or the in the public cloud by using also already there even at edge or in the data centers, because you there also you don't want to trust your admins or insiders, right? It's the same use case across the board. And but I think the biggest challenge is now, effectively think about it, creates a walled garden. Organizations have to be somewhat careful about what they bring in their TCP. For example, with the technologies like TDX, we are running the whole operating system, and Yarslo talked about that they have added all the safeguards in their distribution of SUSE. But if you are bringing a large body of code in your trust boundary, you have to be careful that it doesn't leak your secrets, because enclave will protect from any unauthorized attacks from outside. Like, they won't allow anybody looking into it, into your enclave. So confidentiality, no one can modify it. But if the code running inside your enclave sends your secrets out, nobody can stop you from that. So this is where attestation comes into play, and I agree with Yarslo. Attestation is actually our biggest challenge. If we just prove to a third party, hey, I'm running this blob of code, but you have to know what that blob of code is doing. And I think there is work happening in the industry to sort of provide certain guarantees. There is one project that I lead, called Grameen Library OS. It was designed to run unmodified Linux applications on SGX. But we now also have a version that runs on TTX, which gives you a smaller TCP. So that is one where we want to run smaller amount of code in an enclave. We don't want to run the whole Linux in there in some cases. So I would say that's really what the organizations have to be careful about, that they are focusing on what code they're running in an enclave, and this whole end-to-end guarantees. Someone has to make sure that the system is secure, especially when it's running in a distributed setting. You may have multiple VMs or containers in your workload. You need to make sure all the interactions are secure. If you're using some storage, that's encrypted. So to be able to really build this secure solution, you do need to combine data at rest, data in transit, and then the data in use with confidential computing. So lots of, I would say, software effort and architecture and validation effort is needed. But I would say industry is building a lot of those tools. So we are on a really good path from that perspective. Yeah.
Perfect. Thanks, Mona. Yaroslav, your turn.
Okay, thanks. I have two topics to talk to. The first is easy. It's about the fact that you don't have to modify your applications to start getting benefits from confidential computing. If your application is able to run a VM on top of the Linux operating system, you don't have to modify anything. You just plug it into you find the service provider, hopefully OVH, who support that, and you can enjoy that. You take the SUSE operating system. You don't have to modify your application. That might be clear for some people, but not for 100%. So that's good to just to remind that this is easy. But the difficult challenge, and that Mona already mentioned, that the confidential computing is a great thing, but it's not the silver bullet that magically solve all your security issues. So you really have to remember about those triangle data in rest, when it's stored somewhere, data in transition while it's traveling through the IP channel, and data in compute. That's the confidential computing. You really have to make sure that this triangle is fully enabled, and the data, sensitive data, is not leaving this triangle at any moment. And yeah, even you when you make sure that everything is done, you have to remember that the data will be at your and inside your perimeter at some point of time it has to be secured as well, so that security is a thing that it's there's never end of the security. You're never fully secured. You have to at every second try to improve and find the any weak spot that you have. And confidential computing is a great tool helping you, definitely. Without that, you it would be difficult to be fully secure. But don't stop at that. Remember about that, about all other issues that might happen there. And that's it. Thanks.
Thanks, Yaroslav. And OVH, Francois.
Yeah, I have not a lot to add with all of the, which has been said. Maybe a warning: confidential computing and in-memory encryption has an impact on performance. So our customers should consider this aspect with care, in particular for AI application for which you are looking the best performance. Performance versus cost, of course. As said by Yaroslav, you don't have to change the application, but you size your cloud environment for your application, you have to you have to have a good consideration of using confidential computing, because the performance you may need more nodes, for example, if you are using confidential computing versus when you are not using it. So just an advice to customer: take care of performance when you use confidential computing.
Okay, thanks, Francois. Yes, we saw different visions. The words, keywords like secrets appear about AI, no, and we are sure that around all the federated services, no, is something that confidential computing will help a lot, and the industry is waiting for this. And another word that we receive now is the magic. It's not magic, no. Is clear. Okay, I think that we can close this block. No, it's about no how the industry, has to go deep of this technology and all the features that it can give now. Okay, let's go with the last block of this panel. Yes, we saw the present. Let's go for the future. No, people from innovation, we can do these kind of things. No, no problem if we have a specific mistake. No, the future, we will see in the future. Okay, pues we will have to think about next 5 years. Okay, what is the first is about the role of confidential computing. No, that will evolve in these next years. And the second one is about the key trends and innovation that we have to be aware or we have to should watch for. And how will we shape the future landscape of cloud computing and data security? Basically, as Mona mentioned, no, this is a foundations, no, as a foundation technology to go with these extra capabilities. Let's go, Mona. The floor is yours.
Yeah, so next 5 years, it's interesting. In fact, I have to say that the project that I'm leading in my lab today, I'm calling it pervasive confidential computing. So my take is the confidential computing is going to become pervasive from cloud to edge, all the way from big servers to the small handheld devices. And this is especially true because we now see all the hardware vendors offering confidential computing solutions, right? Intel led the way, but we have AMD, we have we have NVIDIA, and and then all the cloud vendors are already also offering, most of the major cloud players, all big and small. So the fact that we are seeing this deployed today and in the next 5 years, we can safely assume that it'll become pervasive. It'll become the predominant form of computing, and not some, especially with what Yaroslav just mentioned, right? There is a lot of effort that's going in to make it easy to use, because historically we had certain issues as the technology was being developed. We're making it easy to use, yet keeping all the security guarantees, as well as minimizing the performance. So the technology is moving more and more, and over the years it'll keep getting better and better, right? And the other thing I expect is lot of government and regulations to include confidential computing as the form of computing, especially as it makes its way into protecting healthcare and financial data. That needs to happen. That's the only way it can be successful. Some of you may know, like Germany's e-prescription is actually now running on SGX, and I think we are seeing lots of deployments in healthcare and financial. And last but not the least, I'm quite sure the model IP protection, especially large language models, will become the predominant use case. And model IP protection as well as the private user data. So confidential computing is really nice where it can offer these confidential and verifiable workflow. And then people can build solutions on top of that. For example, for privacy of these models or data, or for access control, or even provenance. So we will see a lot of innovation in that space. And last but not the least, we do have to keep getting better at how we do attestation. Like Yaso said, that's the backbone of verification. More and more standards are appearing. Different hardware vendors, attestations, hopefully will work with each other and such. So yes, I hope to see it become pervasive. That's
Thanks,
it. Yeah,
Mona.
yeah.
Yes, Yaroslav.
Okay. So what will happen in 5 years? In 5 years, we will have no use case for confidential computing. What that means. Today, when we are talking about confidential computing, we have to find an excuse. Like I have a financial data, I have the health data, I have to protect it, right? So that's how we define why we're doing that. In 5 years, data centers will have confidential computing as a commodity. You will need to have a use case why you are not running the confidential computing. Yes, we do have certain challenges as of today. How complex is attestation? What is the performance tax you have to pay to run confidential? But the technology evolving so rapidly that in 5 years everyone is going to do that, and you will have to really have a good reason why you are not doing confidential computing in the cloud. That's basically the expectation I have for the evolution of this thing, for the data center, for the classical data center. That will happen. What will not will be finalized in 5 years, that's the edge where it's a little bit more complex, and you might be in more the performance, you might be in more it tight from performance point of view, tight from some other angles. The evolution of edge is definitely gonna happening in direction of confidential computing, but we will, it's a lot still to be decided and to be developed. And that's the probably the next big thing in confidential computing, how we as an industry will be collectively able to tackle the edge use case. That's something it's remain to be fully defined, but data centers will be fully in confidential computing mode, I'm sure. So that was my 5 years prediction. Thanks.
Okay. And Francois, please.
Yes, once again, I agree with what has been said. Yes, I think all our cloud infrastructure in 5 years will be confidential computing infrastructure. So, what will change for us is the evolution of the customer scope that we have. I said the cloud computing started with some tech companies, some software vendors, and we've seen that uh, we had now financial institutions and healthcare companies, which were on-prem a few years ago, and now we have another kind of customer who's very interested in the cloud. It's the defense, army, and all the secret defense stuff like police. And they are mainly on-prem now, but they want to investigate the cloud for all the good reasons of the cloud, flexibility, scalability. And and they won't go to the cloud without full confidential computing. These kind of customers are now using a complex accreditation and vetting process, and confidential computing will help them to be sure that no cloud provider employee can access to the data. Of course, we don't have access to the data of the customer already now, but this will help us to replace a part of the accreditation and vetting process to help this kind of customer uh, who are very important to migrate to the cloud. That's I think our main expectation in the next years.
Okay, thanks, Francois. Yes, we can do like a recap for this last block. The paper of LLMs, the strategy through the VMs, no, and the virtualization that continues, through these foundation technologies as a commodity. No, it's something a word that no that is clear in the data center for the next 5 years, and with all this extra complexity for the edge, no, in these distributed challenges to reach the far edge, okay, that is so far. And more or less flexibility appear in the conversations, and all the capabilities that from Intel, is visualizing and working on in his innovation labs. Okay, for this block. And after the third block, I have a present for you. You have an additional question, okay? An additional question, but in this case, we can speed up, the answer, because the idea is only to reduce to one sentence, okay, for this question. And we will change the order. Okay, if not, Francois is always at the end. We can start with OVH in this last block. Is about is the question we discuss about the future. But all around this conference, around the edge technologies and all these new capabilities and all that we have to do to this with a reality. And if we are, visualizing the edge, no, and maybe we have to think about 10 years, no, that confidential computing can reach, the near or the far edge. How can you resume one sentence or two? It's not at the end. Your prediction, no? The first is that it will be in 10 years, 20, 30. Let's see. And around adoption, no, of this kind of technology, where the devices are not capable, I have not all this extra power to run this extra layer of security. Let's go with Francois. You are the first. The floor is yours.
Oh, so you ask me my point of view about this kind of technology in 10 years. That's correct.
Yeah.
Yes, I think we can't answer to this question without talking about quantic computing. So I'm not a specialist, but at OVH we are involved in quantic computing. We have some qubit available. Um, so yes, the main question will be what are all the encryption technology? How can we still ensure encryption when the quantic computers will be available? If they are available in the next 10 years, but I think it will be the case. So I don't have the answer to the question, but I think quantic computing will totally change the game, and that's my point. I can't say how it will change the game if we will still have the same kind of algorithm, and but maybe it will be totally different.
Okay. Yaroslav now.
Okay, looking at my crystal ball again. So what will happen in 10 years? I think it's gonna be um, legally required in European Union. It's gonna be legal obligation to do things like confidential computing in Europe. I don't. My crystal ball doesn't work for the rest of the world. But I think that many other countries outside of Europe will follow that. That's basically the mega trend that I can predict. Yeah. Thanks.
Okay. And the last one, Mona, your prediction.
I actually, so Yarslo said it. I, by the way, have always said that Europe is leading the way in even in regulations and in this space, right? Their privacy laws are a lot more stringent. But okay, I will make a so I yes, Europe will lead the way. I think rest of the world will follow. But I think it's really this wave of large language models. They will become the primary use case in general for confidential computing. So I would add that. Um, yeah. Uh, yes, I think that's. I would stop there.
Okay.
So, and then this 5-year prediction we said on pervasive, I think to truly have the benefit of that pervasive, it will probably flow into those 10 years, right? Uh, 5 years can go by very fast.
Oh, yeah, yes, it's clear.
Yeah.
Okay, perfect. Thanks. Thanks for your time today. I really enjoy the session. It was very, illustrative, and we have to recommend to the audience. Now we are in, it's a very hot topic here. We have a specific roadmap for the next decade. And following, as you mentioned, from the Cloud Computing Consortium over the Linux Foundation, for instance, they have some reports, no, in the website to get introduced in the discipline. We recommend to go forward in this way. It's like some homework for you, attendees. Okay, and after this, from the European industry, I think that it's clear they have a specific role in technology and in the regulation altogether to have these new services that impacts why not to the end user, to the citizen, no, and his safety. Okay, and let's the end of the session, and for this and to this end, we have to. I have to put one slide here. We have. I don't know if. Okay, perfect. It's only have on the EU industry, only that is working, for the next years around a specific project that is called IPCI for Cloud Edge Continuum. And on Open Nebula, we are a direct participant in this, and all the Cloud Edge industry in Europe is working together to have these new edge capabilities and open source, based technologies. And I think that this is the end of the session. Thanks to be here, and see you. And remember, tomorrow we have more sessions through this Open Nebula conf.
Thank you. Thanks a lot for the opportunity.
Thank you very much.
Thanks.
Thank
Bye.
you. Thank
Remember
you.
to use confidential computing every time you can.
Okay.
And with Intel every time you can.
Yes.
At OVH if you can.
Yes.
Thank you.